Hello everybody. So in this video, I'm going to summarize the chapter 4 of time value of money. So before we get into that, the formulas or the concepts what we have applied in chapter 4, I want to uh, elaborate on that. So we have looked at four concepts in time value of money. So one is the single period, and perpetuity, growing perpetuity, and annuity due. So before we get into the formula, I have told you to remember the conditions. So let me take you to the conditions and then we'll go and see the formulas. I hope this is visible. Okay. So there are three conditions what you need to remember in the time value of money in order to apply, in order to understand which formula to apply. So the condition number one is the C. So the C is nothing but the cash flow, whether it can be receipts or payments. So what you see in single period and the multi period. So typically this is called as C and this is called as C. Okay. So C is nothing but the cash flow. So when you look at um, the single period or multi period, the C is only one time. This is very important aspect that you need to understand. So if you're evaluating any investment products, you can think of a fixed deposit or a lump sum investment in any of the investment product. So if you take any of these two financial instrument also, it is talking about only one time investment. So in order to decide which probably the type of uh, investment evaluation you are trying to do, it's important to understand these preconditions. So these preconditions. So first and foremost thing is to understand whether the cash flow is recurring or one time. If the cash flows are one time, then it is straight away single or multi-period case. And then what you have to do is in the single or multi-period case, you need to just draw the timeline. So this T0 is mainly today and T1 is expected. So in the problem, whatever is given, just try to write down that. Suppose, for example, if I'm investing 50,000 rupees and would like to know what is the value of 50,000 at the end of year one, in that case, let's say 50,000 is for today. And what is the value of investment at year one? So, which means you need to apply the future value because you know what you're investing today and you have to know what is the value of this investment at the year one. The same way, if I would ask, what is the if I have to accumulate 1 lakh rupees at the end of year one, how much I should invest today? Then you have to find the present value. So, in case of single or multi-period case, if you have a timeline, it becomes very helpful. So, let's get back to this preconditions. So, when you look at the problem, the first and foremost thing what you have to see is whether the C is recurring or it is one time. If it is recurring, then it could be possible that it's a case of perpetuity. But however, before concluding, you should all the other two conditions. The second is the time is fixed. So if you see in the annuity, one of the precondition is the T is fixed. For example, in the case of perpetuity, we when we looked at the perpetuity, we identify many keywords, which is very easy to probably distinguish as a perpetuity. So one possible keyword is forever, right? If you see something called forever or it's going to rest for lifelong, so anything which any cash flows which stays forever, then it's a perpetuity. Okay, so if it says uh, 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 so you have to understand the difference between these two. So I've already told in the class also. The R is nothing but what is your expected return, all right? Or what is possibly in the case of company, it becomes a cost of capital, right? Or it can become a risk-free rate of return also. So typically, you are saying that above which you want to earn more in order to accept a project. So G is mainly it's just talking about the growth rate of an underlying asset which you tend to invest. So the precondition one is the cash flows are recurring and the time is fixed, and the C is so these two once these two are met, then straight away you can say that it is annuity. And the second precondition of annuity is whether it is an ordinary annuity or ordinary due annuity due. So in order to understand this, it is important to understand whether the C is in the beginning or at the end of the year. If nothing is given in the problem, then it means that we assume it's going to be at the end of the year, and that's an ordinary annuity. If it is a ordinary annuity, simply apply any one of this formula. But suppose if the C is in the beginning of the year, then it is annuity due. So in order to decide which formula to apply, it's important that you remember these key conditions. So condition number one is C is recurring, time is fixed, and C is at the beginning of the year, then it is annuity due. So please remember this formula, and also in order to apply this formula, you need to remember these preconditions. So now what we will do is now let's go and see some problems. Now what we'll do is let's see an example and then try to uh, apply those conditions what we have discussed. So we discussed three conditions. So condition number one is C is recurring. So let's see this example. If you invest 80,000 rupees in a 3-year deposit scheme, this deposit offers a stated annual interest rate of 10%. How much will you have at the end of your 4 years if the interest rate is compounded monthly? So what are the conditions? So condition number one is whether the C is recurring or one time. So in this example, it's very clear that C is one time. All right. So C is one time. So what they are saying is, so it's a very very clear case that it is not an annuity and the single it is simply a single period case. So just write whatever is given in the problem. So R is 10%, but it is monthly, right? So before that, we need to understand whether we need to calculate present value or future value. If you see this problem, it says that you invest 80,000 in a 3-year deposit scheme. This deposit offers an annual interest rate of 10%. How much will you have at the end of fourth year? So it's a clear so if you draw the timeline, it says that what is the value of this investment at the end of fourth year? At the end of fourth year. And I've told you very clearly that if nothing is given, whether it is beginning year or end of the year, then we assume that it is end of the year, right? So this is T0. So what they're saying is, if you are investing 80,000 rupees today, what is the value of this 80,000 at the end of fourth year? But the very important thing what you need to understand here is it is compounded monthly. If it is compounded monthly, then what you should do is you need to do 0.10 divided by 12. So how much you are going to get? Let's check. Why we are taking 0.10 is because it is compounded monthly. So in that case, so what we will do is we'll compound it, we'll convert that to monthly. So 0.10 divided by 12, we're going to get 0.008. Okay. So now just simply apply the formula. So what is that? We know present value right? And we need to find out the future value. So future value, I already told you that we need to compound it because your profit gets reinvested. So what is the formula? So the present value, so future value equals to the present value into 1 plus r to the power of t, right? So t also you should convert that. So it is saying it is 4 years. So you need to do 4 into 12 because number of month is 12 and it is 4 years, right? So because it's saying how much will you have at the end of fourth year. So 4 into 12, you're going to get 48 months. It is 48 months. So what you have to do, present value is 80,000 and 1 plus r is 1 plus 0.008 to the power of 48. Okay. So if you do that, you get 80,000 into 1 plus 0.008 to the power of 48, 1.46590 into 80,000. So you're going to get, let me put that number, 1.4659. Okay. So 1.4659 into 80,000, you get approximately 1,17,272. So this is your future value. So what does it indicate is if you invest 80,000 in a 3-year deposit and it's not recurring, it's one time, right? So how if the R is compounded monthly, then your value will be 1,17,272. So what did we do? We applied again those three conditions. So C is not recurring, and of course time period is fixed. So if C is not recurring, then straight away it is a single or multi-period case. Okay. So now let's see one problem on annuity. Okay, so now let's solve this problem. So what did I tell you? I told you to look at three conditions, right? So let's see the problem. A person contributes 500 at the beginning of every month. So please understand here, important thing is it's the beginning of every month. So what is our precondition? Our precondition says C is recurring, right? So here C is recurring. So checklist is 1 and T is fixed because it says 3 years, right? So that is met. And so when these two conditions are met, the third thing what you need to see is whether C is beginning or end. So here it is beginning. So it's a clear case of annuity due. Okay. So now let's apply the formula. So let's see the problem. A person contributes 500 at the beginning of every month into savings account at 6% annual compounded monthly. Okay. So in this problem, it's important to understand this. I think most of you will get confused with this. If you see the interest rate, it says that every month into a savings account, paying 6% annual interest. It's very important. So it doesn't say that it's a monthly interest. It's very clearly says that 6% annual interest compounded monthly. So which means that the annual interest is 6%, but it's compounded monthly. So which means that you need to convert uh, to monthly. So which is 0.06 into divided by 12, right? 0.06 divided by 12. So you will get 0.005. So what you have to understand is even though it is compounded monthly, the given interest rate in the problem is annual, right? Because it says paying 6% annual interest rate. So you need to always convert it when the given interest rate is annual, because even though it says compounded monthly, The given annual interest rate is NED. So the same way do it for T. So T is 3 into 12. You're gonna get 48. 3 into 12, 36. Alright, 3 into 12, 36. So now what you have to understand is now whether you need to apply present value annuity or the future value annuity formula. This is could be the one possible question. So for that, if you read the last line, it says what is the value of account at the end of the third year. So which means it is not talking about today, it is talking about end of the year, third year, so which means expected, and so which is future, right? So it's a clearly indicates that you need to find out future value annuity, because here it is talking about a person contributes $500 every month and he wants to know what is the value of this at the end of third year. So you need to find out future value annuity. Due, it's very important. Annuity due, why? Basically because the condition number C3 says that C is at the beginning of the year. If the C is at the beginning of the year, then it is annuity due. So first what we need to do, we need to find ordinary and then convert that to due. So future value annuity ordinary equals to C by R into 1 plus R to the power of T minus 1. Alright. So what is C? C is 500. 500 by R is 0.005 into 1.005 to the power of 36 minus 1. So how much you're going to get? So 500 divided by 0.005, we're going to get 1 lakh, right? 1.005 power of 36 minus 1, 0.1966966. And if you multiply that 1 lakh to 0.1966, you're going to get 19,660. Okay. So 1 plus 0.005 power of 36 minus 1. Okay. So this is future value annuity due. So what we have to do is future value annuity due we need to calculate. Future value of annuity due is future value of annuity ordinary into 1 plus R into 1 plus R. So which is 19,060 into 1.005. So you're going to get 1960 into 1.005. So you will be getting 19,758.3. So this is the final amount. So what did we do? We say that C is recurring, T is fixed, and C is the beginning. And then you apply annuity due formula. I hope this video is helpful. See you in the next video. Bye bye.